Alrighty, so in this video, we're going to talk about a special case of the non-inverting amplifier topology called the unity gain buffer, or the voltage follower. You'll see why it's called that. We already looked at this when we saw the negative feedback little video and that circuit where the output was equal to the input. That's why it's called a voltage follower. But I'm going to go ahead and show you where the voltage follower comes from, and then I'll talk about why it's useful. Okay, so I'm going to go back to drawing the op-amp configuration that we saw originally. I got my R1 here and my feedback resistor here. All right, and then this goes to ground as well, just like this. And this is my V out. All right, and so this is my non-inverting amplifier topology that we just looked at for the last couple of slides, where this is R1, this is RF, and again, my output in this circuit is equal to my input multiplied by 1 plus RF over R1, which is what we determined earlier. Well, there's a couple of different scenarios here which can lead us to a unity gain buffer. What does that mean? It's basically this circuit, but when the gain is 1. Basically, the output is equal to the input, right? This is my input right here. And unity gain, or unity meaning 1, right? A gain of 1, or a voltage follower, occurs when one of three things happen. Either RF goes to 0, right, which leaves us with just V out is equal to V in, or R1 goes to infinity, right, which makes this term 0, which leaves us with just V out equals V in, or both of those things happen, right? If both of those things happen, if I have RF equal to 0 and R1 equal to infinity, then what I get is I get a circuit that looks like this, which we've already seen. I have my input here, and then instead of anything going this way, right, I have infinite resistance here, so I can just completely erase all that. And then instead of a resistor here, I just have a short because it's 0 ohms. I'm saying RF is 0, and so this is my circuit. And so what we end up with again is, of course, that circuit that we saw in the feedback slide, which is here. That's this exact same circuit, right? We're talking about a unity gain buffer or a voltage follower. And again, we're back in the situation that we had, where if I have V in on the plus node, I know that my plus and my minus terminals have to be equal to each other. So then this node is also going to be a V in. And because that node is connected to the output, then V out is also equal to V in. And we are left with a voltage follower because the output voltage follows the input, right? Or a unity gain buffer where the gain of the circuit is 1 if we look at it from this perspective, where V out is equal to V in times 1 plus, and then any combination of things which makes this term go to 0 basically just gives us V out is equal to V in, right? Okay, so that's the unity gain buffer. It's very useful in several different types of circuits, different types of filters where we want to connect, let's say I have, this is kind of outside the scope of what we've learned so far, but we'll probably visit this again when we get into EE221 topics. But if I have some kind of a filter here, or some kind of a circuit here, and I want to connect this filter to another filter, if I connect them directly like this, then what I end up with is problems between the output impedance or output resistance of the first filter and the input resistance or input impedance of the second filter. Again, a lot of these are just words you've probably never even heard before, so I don't want to harp on this too much. But if I were to insert a unity gain buffer right here, then I can actually drive the output of one filter into the input of another filter with no problems. Okay, so this circuit's very useful. I just want to show you where it came from because I know that It's an important circuit moving forward. It's better to introduce it now than to wait until later to introduce it. And again, it's really just a special case where I basically let this resistance be huge, so there's nothing there, and I let this resistance be 0, and that's where I end up with my unity gain configuration, just like that. All right, so I'm going to go ahead and end this video here. And in the next video, I actually don't know what I'm talking. Oh, I'm going to be showing how we can use the op amp as a summer, S-U-M-M-E-R, or an adder. Basically, it's going to sum or add up multiple input signals, and that's one of the many mathematical operations that the op amp can perform. And so I'm going to go ahead and show how the op amp can be used in the summing configuration.